you can see inhalation attributes to 1.26 millisievert of radiation received by the public every year. Then radon health is 25 times greater for people who smoke. So if you're a smoker and you live in an environment that the radon concentrations are high, then the likelihood of you getting lung cancer is also very high. So in the world, radon accounts for about 3 to 16% of all lung cancer deaths in the world. Continuing, so I've talked about the impact, that's the health effects of radon. As I said, it's the second leading cause of lung cancer in the world. So when you're in environments and this radon, as I said, is a natural gas, so it's everywhere. Wherever we are, radon is there because it's a natural gas and it's with us. So the only way to know is to test, to know how much you have in your environment. So as we inhale this radon gas, the daughter, it will decay. 3.82 days, radon has decayed. So when it decays, the daughters, the bismuth, polonium, lead. So the lead is a stable isotope, and as it interacts with the lung tissues, it damages the DNA and increases your risk of getting lung cancer. And according to the US EPA, where a lot of research has been done, it is estimated that 21,000 people die out of lung cancer in the US alone. So what are some of the risk factors? Prolonged exposure. So if you stay in an environment that has high radon levels, that means the likelihood of you getting lung cancer is high. And if you smoke, your age and the time that you spent indoors, because whilst we are indoors and we have all our doors closed, and that means there's the gas doesn't get any escape routes. There's no exchange of air, and you're staying in that room for some time. That means for a long time, that means the likelihood of you getting lung cancer is high, and children and smokers face the higher risk. So I come to my talk a bit about climate change. And I think in the world now, we are all seeing the impact of climate change in the world. And according to the UN, climate change refers to a long-term changes in temperatures and weather patterns. So such shifts could be natural due to changes in the sun's activity or large volcanic eruptions. But since the 1800s, we realized that a lot of human activities, the things that we as humans we are doing, has been the main driver for climate change, primarily due to the burn of fossil fuels like coal, oil, and gas. So as we burn these fossil fuels, generates what we call the greenhouse gas emission that will act like a blanket around the earth that traps the heat inside. So as it traps the heat inside the earth, it raises the temperatures. And we could see what is happening now with these rising temperatures, a lot of flooding, a lot of things are happening due to climate change. So I believe when we talk about climate change, most of us maybe are just thinking about the warmer temperatures that we are having. But the temperature rise is just an aspect of what the change in climate is having on the earth. Let's take it like the earth like a puzzle. You pick one thing out of it and everything it spoils. So the earth is connected like you've made a puzzle. So changes in one can influence changes in all the other parts. So the consequences of climate change now include, among others, as we know, intense droughts, water scarcity, severe fires, rising sea levels, flooding, melting polar ice, storms, and declining of our biodiversity. But one of the most silent side effects of climate change now is how it's affecting radon in the environment. As I've discussed already in my earlier presentation, I said radon is natural, so it's with us. But with a change in climate, is really affecting how radon is getting into our environment. So how is climate change increasing the radon exposure in our environment? So when you take one aspect like the warmer temperatures, so warmer soil temperatures, as the temperatures increase, soil temperatures also increases. So this will enhance the release and movement of radon from the ground into the atmosphere. So radon is in the ground. And as the temperatures become warmer, it moves from the ground and gets into the atmosphere. So according to Bartolci et al., from the studies that they've done, they realized that warmer soils accelerate the spread of radon and allow it to migrate more easily into buildings. And they get into buildings if you have the cracks, the crevices in our buildings and all that. Also, the change in rainfall patterns. At least coming home to my country, Ghana, we've had a drastic change in our rainfall patterns. I mean, months that is not supposed to rain is raining. So we could see the effect of the climate change. It's disrupting the precipitation patterns. Intense rain can create a barrier around the soil, temporarily slowing down radon movement. But once the soil dries out, especially after the heavy rains or during drought, radon can actually escape more readily through the now permeable ground. And what's more, with an increased likelihood of droughts, so like the soils, you see, it's cracked. So if the soils are cracked, you see the gases will just easily escape from the ground and get into our homes. Also the push toward the energy efficient buildings. So when you look at the modern buildings now, increasingly we are using airtight buildings. People are building with in airtight, well insulated to reduce energy use. So this may be great for heating, but it's not so great for radon, because as you are building airtight, that means there's no ventilation going on in your home. So reduce ventilation, which means radon enters the home. It has nowhere to go, allowing it to accumulate to higher concentrations. So radon is there accumulating over and over, like that means it's not getting any pathway. And also due to drastic seasonal temperature changes. Now in colder months, homes are often sealed tightly to retain warmth. That's reducing natural ventilation. Then also, so this can lead to increased indoor radon levels, as I've said already, as the gas get trapped inside. And as warmer air rises, that's during the summer, it escapes from the upper part of the building and it gets into the ground floors and all of that. So how do radon get into our homes? So what are some of the sources of radon in our environment? So the soil radon concentration, we build on soils. So and radon, as I said, is a natural gas that is in the ground. So whilst you build on it, that means this is one of the main source of getting radon into your homes. And how permeable the soil that you built on is also a factor. And the cracks and gaps in your structure. If you have cracks, that means you've created a pathway for radon to get into your home. The level and the type of heating or ventilation that you use in your home also make you know how radon will stay in your house or how it will get out of your house. The basement, the ground floors, the upper floors, and the usage of building, including habits of occupants, how the habits, what some of the habits is, we stay in the house without maybe opening our windows. And as you don't open your window, that means you're accumulating this radon in your room. And the season and the weather also affects the radon concentration in our home. So it comes to the measurements. Now we've known about this radon, how it gets into a house, but how do you know how much you have in your house, how much you have in your workplace, how much you have in your water, how much you have in the environment that you are in. So when it comes to radon measurements, we have the short-term measurements and we have the long-term measurements. The short-term measurements takes 2 to 90 days. And we have different types of detectors for detecting these kind of measurements for the long term and the short term. And we also have the passive and the active. So when it comes to radon testing and we talk about passive detector, a passive detector, that means that detector does not use electricity. And we talk about active detector, that means that detector uses electricity. So most of the time, active detectors are used for short term and passive detectors are used for long term. So some of the short term, we have the charcoal canister, we have the electrodes, we have the RAD7. So those are for short term, and we have some digital detectors too. Then when it comes to the long term, we have the alpha tracks, and the alpha tracks, two types are common. We have the LR15 and the CR39. That's the Lenin resin and the Columbia resin 39. They are the commonly used one internationally in the world. And you have the electric detectors too. And also, if you can see with the arrow, these are the electric detectors that can be used for both indoor radon and can be used for soil radon. And we have this is the digital that you put in your house, so it will tell you how radon concentrations you have in your room by minute. Then this is the charcoal canister that you can leave in your room for some days. You take it to the lab and it will be analyzed. And there's also a short, and there's also a short-term alpha track detector that you can put in your house for detection. Then most of the time, when you're doing the radon measurements, we prefer an environment because, as I discussed earlier, the moment you have a closed environment, that means you are going to have, you are trapping the radon indoors. So when we are testing, we usually want to test in the months that most of the time we've closed all our windows. So these are the months that we really want to test. And we always advise that when you test, at least every year you should test your home to check for radon levels, because the levels changes all the time because activities and all those things changes. So every year it's advised that you test, and if you do any renovation and all that, you make sure that you test your home for radon. So what are the standards that I test my home? How will I know that I'm safe? So when you test your home with a detector, you get a professional to come and test your home, or you buy a detector, you put in your house. After testing, you take it to the lab for analysis, and they give you a result. How do you know that the result that you've gotten, it's okay? So according to the WHO, recommends the action level should not exceed 100 becquerel per meter cube. And some countries have their specific levels. So according to the US EPA, their level is 148 becquerel per meter cube, and the European Environment and Health Information System says between 200 becquerel per meter cube and 400 becquerel per meter cube. And radon varies by season, weather, and building characteristics. So depending on the season, radon levels vary. So that's why we advise that you test regularly, like annually. We test annually if your results is below 100 becquerel per meter cube. And you can test every 6 months if your levels are just at the threshold or above, so that you make sure that you are you know what to do to get the levels down. So still on the radon levels and the safety standards. So if your level is more than 150 becquerel per meter cube, you keep measuring, and if levels are maintained for more than 1 month, you contact a professional radon mitigator. So if your level is between 100 and 150 becquerel per meter cube, keep measuring. If levels are maintained for more than 3 months, contact a professional radon mitigation. And if your levels is below, is less than 100 becquerel per meter cube, no action needed. Breathe easy. So radon in workplaces, I've talked about the homes. In our workplaces too, as I said, it's a natural, so it's everywhere. So we have the higher risk environments like the mining, the underground utilities, water treatment plants. These places, because they're underground, closer to the earth, so the likelihood of they having higher levels of radon is very high. The ground floors and the basements may have elevated radon levels. It may because you might test and it's low. So if you don't test, you wouldn't know that it's high or it's low. So according to there are some levels also for workplaces. So the Occupational Safety and Health Administration sets 925 becquerel per meter cube as the occupational exposure limit in the US. And the Australian Radiation Protection and Nuclear Safety Agency sets 1,000 becquerel per meter cube for workplaces. And in Ireland, their radiation environmental protection agency sets their level to 300 becquerel per meter cube. As I said, every country, depending on the activities and what they've seen, sets their levels. But the level is set in line with the WHO and the ICRP. So what are some of the mitigation you could do if you have high radon levels? So the best mitigation is ventilation. You should have proper ventilation in your home. At least we should be opening our windows, opening our doors for some time to have exchange of fresh air from outside into our homes. And also, if we have cracks and other openings in our buildings, we should make sure that we seal them. It's a gas, so any small opening that it gets, it just seeps through. I think from the building that I showed, it's how radon gets into it gives us the idea of how it gets into our home. So if you have all those cracks and those openings, you make sure that you seal them. And you could also use some barriers. So when you're building, you could put a barrier. They have ways. So this one is being done by a professional. So they know how to do it for you. So if your levels are high, you contact a professional radon mitigator and they will know what to do depending on your level. And we have the soil depressurization system that's using a vent pipe. That means maybe the way you built your house, there's no way you could open your windows and all of that. So they need to install a vent pipe system and a fan that will pull radon from indoor and vent it outside and also bring in fresh air into your house. So I'm just showing you some works that we have done in Ghana to show you levels across the country in indoor and also in the soil. So the red part shows the areas that have high concentration of radon in the country, and the yellow part shows low concentration. And I think I should put in this, radon is also linked to earthquake. It could be used as an earthquake predictor. And we know that from research, areas that are prone to earthquake also are prone to high radon levels. So radon policy and public awareness. So it's advised that countries should have national radon programs. So we have a national radon programs that you could let your citizens know about the dangers of radon and its health implications. So countries like the US, Canada, and European nations have radon action plans. And there's always, in the US, I know January is a radon awareness month. And when it comes to Ghana, we have set July as our radon awareness month. So call to action. That's our concluding remarks. I'm concluding now. Radon can be found in the air outside and can build up inside buildings and homes. If your home radon level is at or above 4 picocurie, that's equivalent to the 148 becquerel per meter cube or 100 becquerel per meter, please contact a qualified professional to install a radon reduction system. If your radon levels are not above, consider increasing ventilation and sealing cracks in your homes. Consider retesting your home every 2 years if radon levels remain low. Also, if you remodel your house, as I said, if you do any changes to your home, please try and test for radon. I'll conclude and say that radon is serious. And it's serious because now, with the impact of climate change, it has made radon a serious health threat. And climate, as I said, is increasing the effect of radon. The only way to know your level is to test. If you don't test, you wouldn't know whether it's high or it's low. Nobody can enter your house and say, no, this room, the radon is high. No, the only way to know is to test. And you can mitigate radon, but you can't get away with it. As I said, it's with us. Thank you.
Thank you, Dr. Irene. We are running out of time. Maybe we can take one question.
Sorry.
From Colette Cabaret. What type of detector is more effective and less expensive?
Okay, please, can I get, I want to get water. Can I give me a minute, maybe? Sorry.
Sure, please take your time. Drink and take the water. So while we wait for Dr. Erin, dear participants, I hope you enjoyed the great presentation about reading and seeing concentration. As you see, there are different standards across the globe in different countries, but as she said, designing the national or international reading dates, I think this is a milestone also, and to bring the community and all the experts who are doing studies and research on these very relevant topics and how to protect the community in different aspects. So please, we invite you to drop all your questions in the chat. Thank you. Over to you.
Yeah, thank you. So the question was, which one is cheaper and effective?
Yes.
Is that the question?
Excuse me?
As I wanted to know is the question was which
What
detector
type of detector is more effective and less expensive?
okay. I would say all the detectors are effective, but the less expensive for me depends on where you are coming from. So for me, being in Ghana, the detectors, we buy them from maybe from France, from the US. So if I'm buying from France, from US to Ghana, it becomes expensive. But if you're in the US or you're in the European countries and you're buying, it will be cheaper for you. Especially, I know in the US, they have different kinds of detectors, and some are they are cheap if you're in the US. But if you come to our parts, it becomes expensive because we need to import. But for now, we are trying to also try and get our own and develop our own detectors to make it cheaper for us. So it depends on your location. Let me put it that way. And also it depends on the type of measurements that you want to do. Do you want to do a long term? Do you want to do a short term? For the short term, if you're using the active detectors are very expensive, like the RAT7 and those, and they are expensive, but the passive ones, they are not expensive. Because when like you buy an LR15 detector, is a roll that you cut into pieces, and you could use it for like a year or two before it gets finished. So if you even buy it for like 1,000 euros, you could use it for about 2 to 3 years before you stop using it. So that is it. If I don't know if I answered the person is okay with it.
That's perfect. Thank you, Dr. Irene.
You're
And we
welcome.
have a few more questions, but you can answer them online, maybe on the Q&A.
Okay. Okay.
Yeah.
All right. So let me stop sharing.
Yes, yes. So now we move on to the next and last presentation of today and of this summer school. Now I have the honor to welcome Professor May Baudu to speak about nuclear science for development, the role of education and training. Education and training form the foundation for empowering new generations of scientists, engineers, and technicians who will drive innovation, ensure safety, and foster public trust in nuclear technologies. Through quality education programs, robust research training, and hands-on experience, we can build local capacities that meet both national and global challenges. So now I invite Professor May Baudu from the Ghana Atomic Commission to share with us her expertise and insights on the subject. Over to you, Professor.
Sorry, a quick interruption on this. I would like to ask the speakers and moderators if maybe you can just speak a little bit louder, because we received a short request from a participant that maybe the sound is not like very smooth. So maybe if you can just double check if whether your voice hears properly. Thanks. Over to you, Dr. Cynthia and Lucilio.
Thank you.
Hello, good evening. Can you hear me?
Yes. We can hear
Okay,
you.
great. And thank you very much, Dr. Irene, for that presentation on radon. So I'm going to be speaking on isotopes, how we use isotopes for our water sustainability in Ghana. As you have introduced, I think the speaker, the moderator has the previous, what's it called, itinerary. He's mentioning Professor Mary Bwedu. I replaced Professor Mary Bwedu on the latest itinerary. So I am Cynthia.
Okay, that's fine. Thank you.
You're welcome. I'm struggling to. Please, is my screen moving? Because it's not moving from this side.
It's not moving, Dr. Cynthia. Would you like me to share your slides?
Maybe, yeah, maybe
Okay.
you have to.
Sure, no problem. Just let me take a few minutes. Apologies, because probably with some overlapping on the program, and I understand sometimes we have some challenges with the presentation, but thank you for making the time for us to take Professor Mary Badu's place and being with us today.
So,
Please, if I think now you're gonna start. Thank you.
all right. Okay, so we move to the next slide, please. Good. So for us at the Ghana Atomic Energy Commission, I work under the National Nuclear Research Institute, under which we have the Water Resources Research Center. So what we do at the Water Resources Research Center is to look at the suitability of our waters for drinking, for irrigation, for industry. So that is what we do. But we are doing that using our nuclear techniques. And the nuclear techniques we apply are what we call environmental isotopes. I don't know if you know what isotopes are. So our basic definition of isotopes are what? Atoms of the same number of protons, but different neutrons, right? So for us, the basic isotopes we use, which are the environmental isotopes, are isotopes of carbon, hydrogen, oxygen, nitrogen, and sulfur. Now we use them to monitor pollution, to track our water and see where the waters are coming from, first their origin, where the waters have been, and how they have journeyed generally through the hydrological cycle. So that is what we do. So if you take any water molecule, right, you know water is composed of hydrogen and oxygen. But did you know that the hydrogens are not the same? We have hydrogen 1, we also have hydrogen 2, and we have hydrogen 3, which is what's tritium. But hydrogen 3, which is tritium, it's relatively radioactive. It's not stable, right? So we call it radioactive. So we deal mostly with hydrogen 1 and hydrogen 2. So you look at the relative abundance of these two isotopes. So isotopes, we measure them by their relative abundance, which one is more heavier in the water than the other. And that is how we express the percentage. No, not percentage, we call it in per mil because the values are so small, so we divide it by 1,000. So it is referred to as per mil. Similarly, when you take oxygen, we also have oxygen 16, and then we have oxygen 18. So when you take any water molecule, whether rainfall, groundwater, water from any river, from spring, they would give you unique signatures of both hydrogen and oxygen, depending on where the water is and the process the water has been through. So we measure these isotopes in our waters, in our environmental samples, to give us an idea what the processes are. Next slide, please. So like I said, normally we use the stable isotopes, hydrogen 2 and oxygen 18. We use them together to trace the origin of our waters and to also see how quickly our waters are replenishing themselves. That is how quickly they are recharging. So you know how much water you have and for what number of population they can use it, what period of time. Sometimes you go to communities, they drill a borehole, you go back in a few years and there is no water. But with the studies of isotopes, we are able to estimate how long this water would stay and for what population. Similarly, we also use carbon-12 and carbon-13 for groundwater dating. Normally, carbon-13 and 12 are used for dating old groundwaters. We also use nitrogen-15 for pollution. You use it to track sources of pollution, nitrates in our waters, in our rivers, wherever they are, we use nitrogen-15. We also use sulfur-34 for tracing salinity, the origin of salinity in our waters. Next slide, please. And for the radioactive isotopes, I spoke about tritium already. We use tritium to date young groundwaters, and we use the carbon-14 to date very old waters that have a half-life of over 5,000 plus years. Next slide, please. So I'm going to be talking about some of our works that we have used stable isotopes to help us solve in Ghana. Next. So our general hypothesis, one, we use stable isotopes of hydrogen and oxygen 18 to give us information about, like I said, the origin of the water, because these isotopes retain their original composition. They do not change even in the environment. When you introduce them, they do not change, whether there are contaminants or other substances around. their signatures remain intact. So we use stable isotopes to trace the origin. We also assume that it's able to give us some kind of information about climate variability. Like I said, it's able to tell you how the water has journeyed, where the water has been through. Depending on the signatures you get, you're able to tell that this water is either evaporated or it is not evaporated. So it gives you an idea about the climate situation in your environment. We also synthesize it with rainfall data. Currently, we are going to implement a project where we are going to use climate data to model our we are going to use, isotope data to model our climate variability in the northern part of Ghana. And this, we believe, will help us to improve on our hydrological situation in the country. Next slide, please. So for every, what's it called? Every stable isotope analysis, this is the benchmark we use. We have the standard plots of hydrogen and oxygen 18. And this plot is a generic plot. This plot was done by collecting rainfall samples across the globe. So we have what we call the global meteoric water line. So that is the established line that we use, the reference line we use for stable isotope analysis. But for each region, it is believed that there will be slight variation. So the various regions, continents have what we call the local meteoric water line, which is slightly, different, but not too different from the global. So what this plot does is that it gives you an idea what your waters, a fair interpretation to give to your water. So when you measure your water and your samples plots around any parts on this plot, it gives you a fair idea what to expect. Are the waters young? So do you have to measure for tritium or do you have to measure for carbon 14? It just gives you an idea on what's the next steps to take, and then you move forward. So isotopes generally help us to, unlike the conventional methods where we use chemistry just tells us the amount of solutes in the water. But the isotopes are able to tell us exactly what is happening. So we complement this information with our chemical results, hydrochemical results, and then we are able to give a better interpretation of what is happening in our environment. Next slide, please. So I come to the projects that we have been running. So most of our projects are from the International Atomic Energy Agency, technical corporations, and then coordinated research projects. And this project is on the Sahel region. If you know where the Sahel region is, that's around the upper parts of northern Ghana. And it includes about 13 countries within the Sahara Desert. Now, the Sahel region has 5 main aquifers. When we say aquifers, for a layperson, these are just like underground tanks, let me put it that way, right? So we have 5 main aquifers within the Sahel region, which is shared by almost the 13 countries. So we are trying to look at what is going on in these aquifers, because if one country it's abstracting more from the aquifer, is going to have effects on what the other countries. So the IEA set up this technical cooperation project for, I think, 5 of the countries within the Sahel region to participate and draw out some of the problems that we are facing within the Sahel region. When there's spillage from one country, it affects downstream of another country. When there's over abstraction, like I said, it affects other countries as well. Next, please. So these were the issues as I was mentioning. So for this project, we use the hydrogeology, we use hydrophysics, we use the conventional chemistry, and then we complemented it with our stable isotopes of oxygen 18 and deuterium. We also use tritium to look at the waters, the ages of the waters, in order to be able to come up with modalities that would help. Next slide, please. So our study area of the Sahel region was done in the northern part of Ghana, both the upper east and upper west. So these are the study sites, and these were the boreholes or the number of wells that were monitored over the period of time. Next slide, please. So from taking our water samples for hydrochemistry and stable isotopes, so we measured for stable isotopes of oxygen 18 and deuterium. We also measured for tritium. Now, the interesting part was the tritium. The tritium data gave us an idea of the age of the water. And relatively, all the waters, it shows that all the waters are very young waters. Now, when you have young waters, they have implications. Same way when you have very old waters, they also have implications. So even though we have most of the waters being young or recently recharged, that's how we call them, we also had few packets that showed signs of very, very old waters. So those waters, for instance, have been singled out and going to be monitored regularly for carbon-14, because when you have old waters, it tells you that you are losing your water, and your water in no time is going to be what? Going to extinction. So you look at that particular situation and look for, what's it called? Remedial actions that you can take, because the communities actually depend. These boreholes we are monitoring, the communities depend on them heavily for their drinking sources and household activities. So this was one of the major outcomes, getting to know that most of the waters in the northern part of the country were recently recharged waters. Next slide, please. We also had another project on the global monitoring of nitrogen isotopes in rainfall. So what we did here was to look at various meteorological stations across the country. We divided the country into 3 main transition zones, because generally the country has 3 different zones. We have the dry savanna, we have the middle belt, and then we have the southern and then the coastal zones. So we try to look at the sources of nitrogen in our rainfall, or what we call precipitation elsewhere. And why were we doing that? Because over the years, from the previous projects, we realized that nitrate concentrations had increased so much in our groundwaters. So we're trying to look for the sources of this nitrate contamination in the groundwater. And one of the things we had to do was to look at the rainfall input, because most of our waters, our groundwaters, showed that they were recently recharged. So our groundwaters are generally coming from rain, they are generally rain-fed. So we try to look at the nitrates concentration coming from precipitation. So this was what the project was about. Next slide, please. Another application here, it's using stable isotopes, which is oxygen 18 and deuterium again, to look at the recharge zones in what we call the Bensu River Basin. Now, the Bensu River Basin is a very important basin in Ghana. Why? Because it contains one of the most important hydrological water sources. We have what we call the Wager Dam, where our drinking water source comes from. I mean, for people who are in western part of the capital, it supplies water to most parts of the capital. So this basin is very important. It has wetlands, it has a lot of activities going on. There are a lot of farming, agricultural activities, pharmaceuticals, and there are also, it's also heavily urbanized. So we're trying to look at the groundwater situation in the area because a lot of people also depend on groundwater for farming and agricultural in the area. And the interesting thing here was that we realized that the recharge rates, that is how quickly our waters are being replenished, is about 7%. So it means that we are not running out of groundwater in the area, which is a good thing, right? So we would have water for irrigation, we would have water for industrial purposes. Next slide, please. So here we also used multiple isotopes, fingerprints. We use carbon, we used hydrogen, we used oxygen 18, and we also use nitrogen 15 in the same Densu River Basin, the one I just spoke about. Next slide, please. To trace agrocontaminants in our groundwaters. So this is the interesting part of this study. Here, the nitrate results. Good. The nitrate results here showed that most of our nitrates were coming from manure and septic tanks. And there was also some denitrification going on. And then soil nitrogen too was a major contributor for nitrates in our groundwaters in the Densu River Basin. So the problem with this plot here is that there is an overlap. You can see the overlap, right? Where the manure and septic tanks, you cannot distinguish between the two, which one is contributing more. And unfortunately, both two are present. They are dominant in the study area. You have manure, you have septic tanks, but this plot here doesn't distinguish the two. So we go ahead to use what we call the mixed seer model. Now the mixed seer model is able to give us to distinguish the two. So that is the next phase of the project, to use the mixed seer model to distinguish between the contribution coming from manure. You want to know what proportion of this is coming from manure, what proportion is also coming from the septic tank. And because there's also soil nitrogen there, because it's heavily, it's an agricultural area and also highly urbanized, you have all these actors playing there, and they are showing very visibly in our waters. So this study helped us to at least narrow down our nitrates contamination to these points, and then also using the mix here to distinguish between the contribution. So this is a clear example of using nitrogen isotope to trace pollution in our water resources. Next slide, please. Okay, so these are just a few of some of our applications. I'm just teasing you for you to know what you can use isotopes for, and also begin to start to look at how you can incorporate some of these isotopes. If for nothing at all, if you are doing studies in water, at least you can measure hydrogen and oxygen 18. You can also do tritium if you have the resources or the lab. The good thing about stable isotope analysis is that it is relatively less expensive, and you don't need so many samples to be able to come to a conclusion. Once you get your samples, and the preservation also, it's not too, you don't need a lot of preservatives to measure your samples. So we look forward to all participants who are here who want to work with them. I thought I had a slide with of the Ghana Atomic Energy and our lab. I would have shown you our lab with, we have a laser ice, liquid water isotope analyzer at the Ghana Atomic Energy Commission. If you want to bring your samples for analysis, if you are looking for collaborations, we are open. I will leave my email behind, and always welcome to receive you into the center. Thank you very much.
Thank you, Dr. Cynthia, for your wonderful. Now the session is open for questions. So I asked the attendees to put the questions now. And while we are waiting, Dr. Cynthia, can you tell what do you mean by young water and old water? Is it 5 years, 10 years, young water? So?
So it depends on the half-life of the, so it depends on what you are using. If you are using, what's it called? Tritium, or if you are using carbon-14. But like I said, carbon-14 is used for waters that are very old, like 5,000 plus years. But then for tritium, you normally get a half-life of 12.3 years. So waters that are within that range, up to 50 years, then you can use tritium to measure those ones.
And what type of detectors are used to measure these trace concentrations of isotope water?
Please, can you come again?
What type of detectors are you using for the measurements?
Okay, so I mentioned that towards the last part. I said we have the liquid water isotope analyzer. It's a laser. We use that one for the stable isotopes of oxygen 18 and deuterium. We don't have a mass spec yet, so we still use make use of the International Atomic Energy Agency for our nitrogen 15, but we have a tritium line that we can use to measure tritium. So we measure oxygen 18 deuterium, and we also have capacity to measure for tritium.
Thank you. Okay, I think there's one more question. There are more questions here. Fatma. If isotope technologies are misinterpreted during crisis, could this information trigger international conflicts? What kind of verification mechanism should be established to prevent this? Did you get it?
No, I didn't get it well.
Let me read it for you. If isotope technologies are misinterpreted during crises, could this misinformation trigger international conflicts? What kind of verification mechanism should be established for preventing this?
But why? What do you mean by they are misinterpreted? I'm trying to understand the question. If isotope technologies are misinterpreted during crisis, could this misinformation trigger? Okay, all right. So this has to do with international relations. So if you take, for instance, the Sahel project, that is why you have to run it with, so we are running the same projects with the other 13 countries within the Sahel region. Whatever we are doing in Ghana is being replicated in Burkina Faso, in Togo, in all those regions. So somehow there's going to be, you have to meet each other and deliberate on the way forward, because these activities, if one country's activities affect the other country, it is important that there is some kind of international, what's it called, relation, right? I don't know if I've answered your question well.
Okay, that's fine. So we can go to the next question. I don't know if you can read it from the Idrissa with Hobo. Are you able to read? Patient.
From Idrissa, okay, yes. Can we extrapolate Ghanaian isotopic water studies to Burkina Faso without risking misleading. Okay, so this is not extrapolating. Like I explained, we are carrying out the same studies. The same studies we are carrying out here. We have counterparts in Burkina Faso who are also carrying out similar studies. So we are not extrapolating. It is for us to, when the studies are a bit localized, it doesn't help because these aquifers are shared. So we are having the same studies being carried out at the same time in these other countries, so that we are able to make be on the same page when it comes to decision making, and not taking decisions just because it is convenient for one country.
Okay, thank you. So maybe you can go to the last question from Maria Jose Gomez.
Okay. Said, what are your opinions in Japan's case of radioactive water discharging disposal in the Pacific Ocean? Is it viable as a general solution for other countries? Wow. That's a tricky question. I think that it has to do with international relations. So I don't think this is not about one country's power over the other. The science is there, discharging into the ocean. I really don't know how to answer this because I feel it's more of, it has to do with relations between countries. That's what I feel.
Okay, thank you, Dr. Cynthia, for sharing with us your expertise on this subject. And I thank the organizers as well for letting me moderate this session. So I now hand over to the organizers for comments and concluding remarks. Thank you.
Thank you very much, Lucila, Dr. Irene, Dr. Cynthia, for your brilliant and wonderful presentations and participations. I think we learned a lot today about different cross collaborations between countries and the great efforts that Ghana is doing, not only in Africa but across the globe, because the Shahels project it's been since several years running through the TC and coordinating research projects, and it will be a great example for other nations or even regions who can be under the same condition of the problems. So, and thank you for continuing the scientific and engineering work there. And I think the production of of nuclear detectors by developing the supply chain in Africa would be a great market and a bunch of possibilities and working opportunities for people there. Because part of the energy future is in Africa, and we have to support and promote those efforts. So this is this is the last day of the summer school. We would like just to present some highlights and remarks. And I would like to invite my colleague Lancina before we conclude some announcements, and Mrs. Eva as well. So please, Lancina, over to you. Thank you.
Thank you so much, Francia. It was a very insightful and informative session during the 10 days. I will want to conclude with a small speech to conclude the first edition of NewComer4Nuclear Summer School. Dear Eva, dear Florencia, dear speaker, dear moderators, and dear participants, by initiating the first NewComers4Nuclear Summer University, I had this dream and I presented it to my team at national and international level. How this idea will be transformed into concrete action. I shared it with two valuable women from different generations, Eva and Florencia. Eva, a lover's the design of the summer university to be in touch with global nuclear skills. Russia was the keeping my alter ego in this initiative with her well-done work, genius, and also this connection. Russia, the work Aulika allowed us to complete the entire agenda by following Eva's advice in less than 2 weeks. The rest need to be refined with clarification and constructive exchange and dialogue. And it is also took us 2 weeks. In a month, the baby from the summer university had just come off our imagination to be placed under basketball form. Audacity, luck, and perseverance, the ecological spirit of continuity in ideas allow us to be where we are today. Thus, we are able to concretely realize this first edition of NewComers4Nuclear Summer School with more than 20 speakers and as many moderators. It is very for 40 skills that we have put together for the summer university with a desire to push knowledge among the newcomers in the nuclear field. Dear professional, and also took us 2 weeks. In above, the baby from the summer university had just come out of an imagination to be placed under possible form. Audacity, luck, and perseverance in a collegial spirit of opportunity in ideas allow us to be where we are today. Thus, we are able to concretely realize the first edition of a newcomer for summer school with more than 20 speakers and has many moderators. It is very for 40 skill, and we have put together for the summer university with the design to push knowledge among the newcomers in the nuclear field. Dear professional and nuclear enthusiasts, I would like to apologize for some shortcomings and inadequacies recorded. It is a human work and cannot be perfect. I wish with ever influential that this adventure of the summer university of NewComers4Nuclear be placed on the global agenda of nuclear activities. And for that, we should work for all of you. We wish to build a community of reconstruction of a learning society by focusing on a global skill without any discrimination. I would like to reiterate a special mention to WiNI Global with all its expert group, to WiNI Africa, to World Nuclear Association, to WINS, to all of the consultants from Africa, Europe, Asia, Oceania, and America. Long live the NewComers4Nuclear Summer School. Forward to the next edition. I thank you from the bottom of my head. Thank you so much.
Thank you, Lancina, and for all the wonderful message that you've been giving to us. And thank you for bringing this initial proposal to all of us and make us part of this project. So please, Mrs. Eva, if you would like to say a few words before we share further announcements.
Thank you, Florencia. Thank you very much, Lancina, for your kind words. First of all, a big thank you to today's two speakers, Dr. Cynthia and Dr. Irene, and to our two moderators. It has just shown, today's presentations have shown how rich the nuclear field is and how many different applications there are. And also it brought some enlightenment about radon, which we not may always be aware of, and also of isotope hydrology applications. So thank you very much for that. Last not least, I would like to thank Lancina, who's the initiator of this summer school, to Florencia, who is the implementer to this for this summer school. I'm just a little person at the back who was supporting a little bit. So all the thanks go to these two persons. I don't know why my name figured as the first one. It should actually be the last one. So a big thank you and a big applause to Lancina and Florencia. I thank you, all of you who have persevered until the 10th day. That's really great. So now we will make a small test of how much you remember, and Florencia is going to tell you more about that. And I think there is just a huge demand for this type of events, not just on the African continent, but elsewhere as well. And I think we will see how we can have more such events and a broader education for all those who are interested. So a big thank you to all of you. And I wish you all the best in your professional careers and in exploring the nuclear fields further. I hope we have aroused your interest so you will know where you can tap in. Thank you very much.
Thank you very much, Mrs. Evan. It's been a great privilege to work with both of you. Before I say my final remarks and speech, I would like just to share the announcement of the follow-up about the test. I'm just drafting a quick message for the instructions, how we will take the test. Can you hear me? I think I lost connection. Yes, I'm back. So I'm sharing two links. First of all, through the chat. Let me just share the screen, and you will see what you will find. Yes. So the first one you will see is the survey of satisfaction of the school. School. We will really ask your kind support to answer the questions before Thursday. Thursday 11 will be the allocated time for the test. It will be the same time as we have been taking the lectures this time. So the test will be open from 7 to 8 p.m. And this survey, if you can complete it by Wednesday, midnight in your time zone. So the only requirement is this survey should be made before the test. We will check who's been answering because this is a requirement before you are taking the test. So you will see several fields that you have to complete, email, country, gender, nationality, and so on, because all these data will be very valuable to know the background, all the specialties that you've been studying before, and also how to improve part of our program. And maybe some of the thematics for next year, how we will be covering the content, and part of the course evaluation and content, how everyone we did it, like because we need to have some feedback, how we did things, what to improve, what to change, what to modify, and everything. How is the effective implementation of this online format, and all your feedback. How will you improve the school? Maybe what you would like to see in the coming editions, and probably if you would like to recommend this program to a different friend. Maybe 2 or 3 sentences of your experience during this innovation training course of summer school content. Probably will take you maybe just 10 to 15 minutes to complete this short survey form, but it will really help us a lot to see how we did it. And then the second link I'll be sharing, it's the lectures. So for all the lectures you've seen from day 1 to day 2, you will be finding all the lectures content, presentations, the information you can download them. We encourage you to check the lecture notes before the test, before the quiz that we'll have on Thursday. So you can have them open while you are answering the quiz if you would like to check something. You'll have 20 questions, multiple choices. It's not going to be hard. We don't want to make things complicated. And you have the time of 1 hour to take the test. In case that something is happening, you have an emergency, there's some doctor appointment or very, very specific case that you cannot take the test in this time, please let us know and we will reopen the link for those ones that you cannot make it on time. But we really encourage you at least just to assign this specific time in your tight agenda or activities to complete the test. So once that you complete the survey form, you will be having the permission to make the test. And these two requirements we needed, plus 80% of attendance, we already marked your attendance for most of the sessions to receive the certificate. After the results are coming out from the exam, probably you will be receiving by the 3rd week of September your certificates. I don't know if anyone has any questions so far here.
If you look
Maybe.
at the Q&A, Florencia, people would like that you share this information by email as well.
Yeah, so Q&A content will be shared. It's everything based on the lecture notes. It's multiple choices, questions is not hard. And specifically, you will be having the chance to get your notes. The recordings will be available after the summer school at this moment because the communications team is on the way to upload them on the YouTube channel. But you will have the lecture notes and more specific format about the band will be shared through email. The exam link will be sent 15 minutes before the time. So it means on Thursday, 7 p.m. Vienna time or your time, we will be sharing the link through email and also in the WhatsApp group 15 minutes before. And then Lencina, Mrs. Eva, and myself will be on the chat on WhatsApp in case that you have any questions or difficulties to take the test to respond to any of those comments. So if any of the participants have any questions, please. I hope everything is clear, but we have your email, you have our email contact. So in case that you have any other suggestions or additional doubts about this, please let us know. I'm dropping in the chat the information that I just told you. Any questions, please? Suggestions? Okay.
You will all
And
do fine, don't worry too much, okay, because you have heard everything and the questions are not difficult. So please just review a little bit the lectures and you will be fine. You don't need to spend the next week studying, okay?
yes,
Hi, good
thank you.
evening.
Good evening.
Florencia, 7 p.m. In Vienna's time, I think it's GMT, right?
Yes, it's the same time that we've been using for the summer school sessions. It's just 1 hour.
It's not GMT, it's GMT +2, I think. It's Central European summertime. So now in Vienna, it is 8:30 p.m. From which region are you, Aisha?
From UAE.
Ah, you are from UAE, okay. Okay, so it's 2 hours, you are 2 hours ahead, I think.
Yes, here is 10 p.m. So it's,
Yes.
you know, almost sleeping time here.
Yes, I know. Sorry about that.
No, that's okay.
So it's 7 to 8 p.m. Vienna time. It's the same time that we've been utilizing for all the 10 days of the school. So maybe you can just mark your calendars and I can send an invitation calendar to all of you that you put it on the agenda. I think that will make things easier. Yes, I already shared those links on the WhatsApp group. Please, if anyone has any additional questions, we would like to hear from you. Oh my goodness, this is sleeping time in Pakistan. We really ask you to make it the late lesson for please, Noreen. It's just like a few minutes. I'm sure you're super smart, and then you won't take a lot of time to do the test. So, any additional questions before we close today's session? No. Don't worry, the test won't be heavy. It's just like it's a recap of what we've been going through. That's very easy. So let me just say a few words before we conclude. So dreams are transformed into ideas, and ideas happen. Today we are seeing an example through Newcomers for Nuclear Summer School, bringing a seal of prosperity, knowledge, innovation, unity, ambition, how the nuclear sector can transform borders, countries, and cultures. We thank you, each of you who made this program possible, all the speakers and the moderators with a high commitment to the program. Each participant from their homes, offices, and challenging places to take the course, and with a strong desire to learn. Thank you to all the organization team, to all the supporters, WiNI Global, Newcomers for Nuclear, the groups of expertise, nuclear professionals, consultants, entrepreneurs, scientists, engineers, who extended your warm support and cooperation hand to us. To Mrs. Eva and Lancina, it's been a great privilege and honor working together to put this on. And thank you, Lancina, for having this energy and compatibility of working together by distance. I hope we can improve the next edition, bringing a different content to the community. So let's continue putting this program in the global agenda across every nation and carry the seal of humbleness to spread the benefits of nuclear energy, offering to the world for sustainability. So thank you from the bottom of my heart to make these 2 great weeks a great journey and having this great initiative together. So I hope all of you can open your cameras. It will be great if we can have a group picture. I think all of you are allowed to open your cameras. We just want to capture this great moment. Thank you, Dr. Ariane, for staying with us. I think all the participants are able to open your cameras. Let me just check one more time. I don't know what's going on. I'm sorry, sometimes Zoom has a lot of tricks and techniques.
Yes.
It's very challenging. Sometimes it restricts some permissions. But since we will take this picture from panelists, but then we will also drop an open link because we want to collect each participant's photograph profile. So maybe we can do like this collage also, just for this to have it on the records, but also I'll make a link where you can maybe just drop your picture with your name and nationality. Then we'll have like this combination of all of us together. So maybe just if you can give me your biggest smile to have this in the recap. 1, 2, 3. Okay, great. Let me just take one last picture. And 1, 2, 3. Great. So I'll be sending you all the calendar invitation for in case someone is not able or you have an emergency, please just let us know and then we will keep the link open for you and your picture also because you're part of this first journey and we hope to hear your testimonies after we conclude this program. So we really thank you for all your entire support these 10 days. It's short time, but it's a lot of work behind, not only for us, but also from you because you made this time possible in your activities, daily activities. So that's all from our side. Anything else that you would like to add, Mrs. Eva Lancina?
Just another big thank you to everybody. It's really heartening to see all this enthusiasm in the background and your eagerness to learn. That's really wonderful. I believe in lifelong learning, so I'm learning every day, and this has just been another opportunity for me to learn some new things as well. So thank you for that.
Thank you very much. So this is the end of today's session and the end of the first edition, and we hope to keep counting on your support. WhatsApp group channel will be open for all of you. Any events, conference, trainings, activities that you would like to share, the chat is open. And also to the community, in case that you have a program and you want us to distribute an invitation to all the contacts that you've been acquired from this program, we will be also happy to do it as well. Thank you so much, and we see you until the next time. Have a very good rest of your day.
Thank you.
Thank you.
Thank you, everyone.